is always very, very important that we draw the figure or the diagram. It's always very important we draw the diagram. So let's go ahead, analyze the question and draw the diagram as it is. So the question says a ladder of length 6.5 meters lays against a vertical wall. If the top of the ladder is 3.6 meters from the foot of the wall. So let's do this. Let's draw the wall first. We have the wall. Let's assume this is our wall, and the ladder is leaning against the wall. So definitely we have the ladder this way. We have the ladder this way, and it says a ladder of length 6.5 meters. A ladder of length 6.5 meters lays against a vertical wall. So the ladder is 6.5 meters, and further on it says if the top of the ladder is 3.6 meters from the foot of the wall. If the top of the ladder is 3.6 from the foot of the wall, it means that this is the top of the ladder and it is 3.6 from the foot of the wall. This is the foot of the wall or the base. So the top of the ladder is 3.6 meters from the foot of the wall. So we have 3.6 meters as the height of the wall. That is the height of the wall. And further on, the question says, calculate correct to two decimal places the distance from the wall. This distance from the wall to the foot of the ladder. You should calculate correct to two decimal places the distance from the wall. The distance from the wall to the foot of the ladder. So the question is asking us to calculate the distance from the foot of the wall to the foot of the ladder. So we have this here. That is not given. So we can decide to represent that side with a variable. For example, let's say x. Okay, so we represent that side with x, and you can also decide to represent all the vertices with variables or letters. You can put a letter here, for instance, A, B, C, and you are good to go. But let's also do the other way by representing this side with a variable. That's x, the unknown length. So let's go. This is now Pythagoras theorem. Here is 90. The angle here is 90. So it's going to be a Pythagoras theorem. So we go ahead, and what we are going to do is that in Pythagoras theorem, the square of the two shortest sizes, the sum of the square of the two shortest sizes equals the square of the longest side. The sum of the squares of the two shortest sizes, that's this and this, equals the square of the longest side. That means 5 squared equals length x squared plus length 3.6 squared. That means when you square this and add them, you get this, as I said earlier. So let's move forward. We are going to 40. This implies that 42.25 equals x squared plus, we also find the square of 3.6 and a half, 12.96 here. Okay, so now we are going to group our like terms, and by grouping we have this 42.25. So when 12.96 comes over the equal sign, it becomes negative 12.96 plus length x squared. So this implies that, so this implies that 229.29 equals length x squared. So that is going to be this. So what do? We are finding x, but not x squared. So we introduce square root on both sides. We introduce square root here and then square root here. So that is going to be, this implies that root 29.29 equals root x squared. So remember, this is the same as x squared. Doesn't matter with the bar. The two bars at the sides of the x only tell us that we are looking for distance of x. That's all. So therefore, when we come, what is the square root of this? That is going to be plus and minus 5.41202, and then in that order it continues. The numbers continues. That's why I put the 3 dots. So we have this. The reason why we have plus and minus here is that we are using the square roots. We are using the root, so we must have plus up and negative down. But what will the final answer be? Stay tuned and watch. So we have this. So this is going to be that, and this square here will cancel the square here. This will now be equals x. So this implies that, so therefore x equals 5.14. X equals 4. 1. You know why? The question said we should calculate correct to 2 decimal places. Calculate correct to 2 decimal places. So we are leaving our answer in 2 decimal places. So let's move 1, 2. That is the 2 decimal place. If it is 3 decimal places, then we are moving 3 times. But here is 2 decimal place here. So we move 1, 2. Therefore, our answer is going to be 5.4141. Do you wonder why we don't have the plus and minus here? Or do you wonder why we only have plus or positive 5.41 without the negative? And the reason is we are talking of distance. We are talking of distance, and in distance, we cannot have a negative distance. We cannot have a negative distance. We have learned that zero is greater than any negative number. 0 is greater than any negative number. So if 0 is greater than a negative number, let's assume this is A. So if 0 is greater than a negative number, then you cannot have a negative distance. That is why we ignore the negative and we have only the positive here. So we come down and we say this. You see, therefore, the distance from the wall to the foot of the ladder is the distance from the wall to the foot of the ladder is 5.41 meters, and that is that. And congratulations if you start for the exams and you got this. So guys, I want us to get something here. Whether it is a must that we always introduce this. Is it a must that we always introduce the square root? No, it is not a must, but that we are coming next time with the explanation of that. If you want to use the root, what else can you do? What else can you do? So watch out for our next videos. We will get that explained. So guys, if you enjoyed watching, please subscribe, like, share, click the notification bell, and don't forget to place your comments below. They are very important. Ask your questions, tell us your views, your mind, whatever you think from our videos, the way we do things in here. Put it below. Let us know what is in your mind. We are coming up sometime with more of the questions solved in here at